In this question, we are going to combine what we have learned from graphing our kinematics or graphing our motion and our kinematics equation to try to solve a problem about a stone. So in this question, we say a stone is thrown vertically upwards. So I've drawn the stone here. This side. Okay. And the variation with time t of the displacement s of the stone is given. So it's going to go like this, like this. I think to make my diagram a little bit more accurate, I will put my stone here. So this is the beginning position of the stone. Stone will travel up with a velocity of u, okay, because you are throwing the stone. So there's an initial speed. And of course, the stone will be able to travel until a highest position. So if you have ever thrown anything in the air before, you will notice that as it's going up, it will slow down and stop. So this is at the highest position, okay, where the stone is here. So this position, right, your V is actually equal to 0. Because your stone, as it travels up, it will slow down, slow down. How can we confirm this? Well, you can look at this gradient, right? This gradient here, from here all the way to troop, where the graph is flat, or gradient decrease until 0. So from here to here, okay, I'm just going to, not to make the graph too messy. Here, gradient decrease until 0. Meaning velocity decrease until 0. Okay, so that's why we learn gradient. That's why we learn how to read and interpret the graph. It tells us what is going on. So by the time the ball reaches the maximum height, it will stop, but it won't stay there, right? It will go down. You're right. So let's say we reach the maximum height, maybe this point somewhere here. I will try really, it's a bit hard to tell where that midpoint is. So I'm going to judge by I, 1, 2, 3, 4. So maybe somewhere here, the gradient is 0. Okay, the highest point. Okay, then it's going to travel down. All right, so this part here, you can see the gradient is increasing, 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 increasing. So from here onwards, the ball is falling downward with increasing velocity. Okay, so this part here, I will say gradient increases. This means velocity increases. Okay, so why is there negative displacement? Because if you look at this, from here going up to coming down, my ball is always above the 0 line. This starting point is the 0 line, s equal to 0. This point here, s equals 0. So for the first 2.5 seconds, the ball was above the starting point. So it went up, it comes down. But it's not going to stay here. Not going to stay here because there's no table, the ball will continue to fall down. All right, so just to give you a few tips here, this one here, you return to initial height. Okay, this means after this, the ball will continue to go down faster and faster. That's why the gradient is still getting steeper and steeper after 2.5. So here, t is 2.5 seconds. Starting point here, t equal to 0. So drawing out all these things is very helpful, especially if you're like too many information. Drawing a picture is good. So this one looks like halfway there. So 1.25. This t is 1.25 seconds. Okay, so it drops all the way until 3 seconds. So probably at 3 seconds, the ball is here. Okay, so I'm just directly interpreting the entire graph from start to finish before we even read the question to show you how rich or how much information there is inside the graph. Okay, this is t equal to 3 seconds. So this portion here, I'm just going to write here to here, negative s. means it's below starting point. From here onwards, positive S, above initial position, starting point. And at this point is where we return to original height. Okay, so there's a lot of information, but let's see what the question wants from us. Using the graph to describe, without calculation, the speed of the stone from 0 to 3 seconds. So the entire journey. You see, I've just done this here. The speed will decrease to 0 and then increase. But if they talk about speed, you don't have to mention the direction. So velocity means you will change direction. The ball go up and then come down. So I'll put a note here. This is speed. So magnitude only. I mean, you can write about direction, but it won't give you any marks because it's not really related. So I will say something on the along the lines where the speed decreases because it is on the way up. Okay. And then this until the stone is stationary or not moving, or at rest at t is equal to 1.25 seconds. Okay. Then after that, you can continue and say stone, then F. Increasing. You want to use accelerate, decelerate also can, but I'm going to talk about speed. I will stick to speed. So stone then have increasing speed until t equal to 3.0 seconds. So you could add here at t equal to 0 second onwards, the speed decreases until the stone is stationary at 1.25. So the first statement here, you mentioned speed decreasing. Okay, you mentioned until the stone is stationary at 1.25, you get 1 mark. Okay, then you mentioned that the stone increasing speed after that, then you get 1 mark. Then or after. All right. Okay, moving on. B, assume air resistance is negligible. Therefore, the stone has constant acceleration. So again, you see the keyword constant acceleration. Yay! We can use your Stuva equation. Okay, so we have to list down. Calculate for the stone the speed at 3 seconds. So since we have a nice drawing that we drew just now, I'm going to transfer it over here, okay? Okay, so this is my drawing that I did just now, and maybe I will list down my STUVA to figure out which equation I should use. STUVA. The time is 3 seconds. Okay, means we know the displacement. Really, yeah. Can we read from the graph? Unfortunately, cannot lor, because you see, I know it's here, but they didn't give any values on the y-axis. So you may be like, cannot do the question, something is wrong. You have to trust yourself. What you don't have in the question, you don't need. What you don't have, you don't need it now. You know that song? Maybe it's a boomer moment for me, but you don't have the y-axis, so you just, nope, sorry, bro, we don't have this, okay? Right, so if we take 3 seconds, means there's an initial velocity here, u, which we maybe have to think about. And then, did they give us u? They didn't give us u also, leh. Okay, so then you go like GG lor, they didn't give us u. Maybe they want me to find v. Okay, so if I take this one as initial, and 3 seconds later, the ball is here. So I'm taking this one as final. I'm a bit stuck, bro. Let me explain to you why we're a bit stuck. Too many unknowns. Okay, remember I said that you should have at least 3 known things. If not, you cannot solve the equation, right? So right now, I don't have S, I don't have U, and I don't have V. So, maybe I need to change my strategy because there is something that I can use, which is this 1.25 seconds at V equal to 0. So instead of taking initial position as where the ball is being thrown, okay, I maybe don't want to start here. I start from here. Miss, can like that one, meh? Can. Where you start is up to you, as long as you do the relevant modification. So we don't want 3 seconds here because we are only taking the motion from here all the way to here. So you think about, how long is this time? Well, I know that this is 1.25 seconds and this down here is 3 seconds. So what should I do? I will take 3 minus 1.25. Okay, because the time interval is different. All right, so now my U can be 0. I can find my V. Okay, now let's think about G. Okay, so it says here that air resistance is negligible and the stone has constant acceleration. So this part here, maybe you know this or maybe you don't know this, but let me explain a bit to you. When the stone is falling, and we call this free fall, we'll do this again in the next few chapters. We will repeatedly see things falling in gravity. So free fall means falling under the influence of gravity alone. So the force acting on this F is equal to weight, which is equal to mg. So if F is equal to mg, but F is also equal to ma from Newton's law, this one is Newton's second law, Newton 2, okay? I can combine this together and say ma is equal to mg, so A is equal to g. Okay. So I could tentatively put g here, which is 9.81 in your data booklet. Means not 10 meh? No lah, you level up already. So when you level up, your significant figures have to level up. 9.81 is what we use in CIE A levels, all right? Okay, so there's another issue here before I start using the equation, which is the issue of sign. Where is gravity acting? Gravity, if you look here, is acting downwards, pointing down. See this? So if it's pointing downwards, I need to come up with a sign convention, or rather, the question already came up with a sign convention for me, which is upward is positive, downward is negative. There, positive S, negative S, so I best stick to it, meaning this G has to be negative. Okay? So I will draw here, and the gravity, or the acceleration, is equal to negative G. Just here, negative G. Okay. All right, so choose the equation with no S. V is U plus AT. So my V, we want to find. U is 0. A is negative 9.81. And T is 3 minus 1.25. Okay, and this one will give you 17.17 meter per second with a negative sign. All right, let me try to change color first. Okay, so negative sign here. What does this negative sign mean? Remember I say examine the negative sign. This negative sign here means the ball is moving downwards, in the downward direction. Okay, 17.70 or 17.2. But means they say speed ma. So speed means magnitude only. You can choose to omit the sign. I think they're being nice because they foresee that this is challenging, so they ask for speed. But you know better, this is negative. If you do the Stuva equation calculation properly, we do a Stuva equation calculation with the sign, if you're faithful to the sign, the negative should reflect here because this one is moving downwards. Okay, so in this part, we learned that we have to be smart about taking the time interval. If you choose t equal to 0 as your starting position, you don't have the initial velocity. You cannot solve the question. That's why I chose t equal to 1.25 because I know the velocity here. The initial velocity is my 0 here. This one. Okay. All right, so where are the marks? If you choose the right equation, you get 1 mark, C1. Okay, any equation that makes sense now. All right, substitute, you get mark. Final answer correct, you get mark. You should not put a negative sign because it is speed. If it's velocity, you should put a negative sign. Okay, let's move on to the next part of the question. You are now asked to find the distance traveled from t equal to 0 to t equal to 3 seconds. Okay, I'm going to stuva myself out of this again. But do you want to find the distance traveled? So you may be thinking, teacher, can I put 3 here? Sure, but you still don't have the initial speed, remember? Okay, maybe I should stick the picture here for us. Okay, now the picture is there behind my head. So you may be thinking, I want to find the distance traveled. So I need to find this whole go up, turn around, come down, total distance. But you see, your problem is still the same. You don't have your initial velocity. Eesh. So if you start from here 0 and you end up with here s, not only you cannot find the distance traveled, which is the length of the yellow highlight, you will find the displacement, which is here to here. Here to here is your s. In fact, s is a vector, so this is negative s. So it doesn't work. What we need to do is we need to find the distance from here to here. Let's call this S1. Okay, and then we times 2. Because you go down, it will be negative S1. And then we need to find the distance from here to here, which is S2. Does that make sense? There are many ways to do this question. How you chop up your motion is up to you. Okay, so I'm gonna delete this one. You can either find S1, and then you find the total displacement S1 plus S2, and then you just add them together, or you can just find S1 and up to you. Okay, so I think what I'll do is I'll find S1 first, and then I will use S2. But you see, I want to avoid you like the plague, because I don't have this. This is very problematic. So I will avoid t equal to 0 at all costs, meaning I'm sticking to here. I want to find the distance from here all the way down to here, but I don't need to use u. Teacher, can? Can. I stick to the same initial here, final here for S1. Okay, so let's find S1. The time now, because I'm only taking the highest position to S is equal to 0, this final position. So what do I know? I know the initial speed is 0. I do not know the final speed here. Don't know. So I'm just going to put quotes. Do I know the time though? Yes. I know it is 2.5 minus 1.25 seconds. So the interval from starting point here to final point here. And this one we know, Lord, negative 9.81. Wow, teacher, we can use the equation with no v, correct? So then, if you're familiar with this, we're going to use S is ut plus half at squared. So I'll substitute inside S1 is equal to 0 plus half negative 9.81. 2.5 minus 1.25 is 1.25, okay? Square. And this will allow me to find S1. If I press my calculator, 9.81, 1.25 square. This is negative 7.66. Why negative sign? Because your final position is below the initial position. That's why your S1 is negative. Okay, we can keep it there. Don't worry about it. Now let's look for S2. So for S2, you need to stuva all over again. STUVA. Why? Because the time interval is now different. If you are treating this one as S2, okay, let me change color for this. Let's use green. S2. So now this one is your initial. Down here becomes your final, behind my head. Here's your initial, here's your final. So the time interval is 3 minus 2.5. Okay, so 3.0 minus 2.5, 0.5 lah. What's the speed here? If you take this initial, do you know the speed? We don't know. We can find, I guess, but I would like to not look for it. So now we should move the initial. So oftentimes this will happen to you when you solve a kinematics equation. You think you have enough information, but you don't. So take your time. Now I'm going to move the initial here. Okay, meaning this one is no longer S2. This one becomes S1 plus S2, the whole length. Now we add them together, then can already, okay? So this one won't be 3.0 minus 2.5. It'll be 3.0 minus 1.25. Okay, and the u is 0 because I love the u equal to 0 so much, you know, it will help me solve my question. I don't have v. This is negative 9.81. So because of this, I'm going to still use the same equation. S1 plus S2 is ut plus half at squared. All right. So substituting the values in, this one will be 0, S1 plus S2. This one is half, negative 9.81. 3.0 minus 1.25. I minus in my calculator lah, 1.75. Okay. So from here, I will get S1 plus S2 is equal to 0.5 times 9.81 times 1.75. This will give me 8.5, 9.81. Oh, there's a square here. Did I miss out the square? Okay. Paranoid time. Square. 15.0. Okay. Meter. I generally take 2 to 3 SF. So hence, you can then say total distance is equal to 7. This is also negative. For the same reason, it's downwards. So total distance will be 7.66 plus 15.0. We drop the negative sign because distance is scalar only, magnitude only. And this will give me 22.66. I guess you could write this one as 22.7. Okay, so the total distance traveled, the total yellow color pathway is 22.7. 23 also can now. All right. So the thing is, this example is teaching us that when you want to use your Stuva equation, you have to be pretty intelligent in selecting where you start. If let's say you choose a point that don't have the initial speed, and then you also don't have the final speed, almost confirm you cannot solve. Okay, so try to find a point where you know the initial conditions. Initial conditions are very, very helpful. Like for example, I always go back to 1.25 because I know the speed here is 0. So I can always take my starting point here and then adjust the time interval accordingly. All right, so this is the equation. So now they want you to find the displacement. If I want to find displacement, what should I do? I already have all these numbers, right? I should take 15 because okay, let me draw this again. It's a bit messy. Your ball is going to travel up, down like this. Okay, so what we know is here to here is 7.66. I also know that from top to bottom, here to here is 15.0. And the displacement is actually here. Let's say I call this X. Okay, because here is 0 second, and then down here is 3.0 second. Let me zoom in a bit. Okay, so if you refer to the diagram just now, you go up, S1 7.66, S1 plus S2 is 15.0. So what to do to find S? So x will be equal to 15.0 minus 7.66. Okay, so this one actually is pretty good. It tests whether you understand the idea of displacements or not. So if let's say you do this, you can keep your answer this way, 7.34 meter or 7.3 meter, 7.4 meter. Okay, but direction. Which direction? Well, look at your starting point. You started on top, you ended below, right? Like this. So it is negative x. Negative means downwards. So when we did this, we are just looking for the magnitude. But actually, it's downwards, below the original position. Okay, so make sure you understand the difference between displacement, which is the length of the purple arrow, and distance traveled, which is the length of the black color loop, which we found using quite different methods. We have to find different sections and add them together. All right, last part of the question. Draw the variation with time t of the velocity of the stone. Oh, they want us to sketch out VT there. Dude, we got so many information that we calculated, right? Right? Okay, let's see. I know that my ball, okay, I think you are quite tired of the ball right now. It's like this. Okay, teacher, you say we got a lot of information. I got nothing, man. I know that here, T is 1.25, V is 0. That's a lot. Okay, let's put that in. 1.25 is here and 0. Okay, let me plot properly. This is your favorite point. We use this so much in our calculation, right? Okay. Are you sure we don't have any other values? We do have the velocity at 3 seconds, right? Let me show you. Here. The speed at 3 seconds, 7.2 meter per second. So what I do know is at 3 seconds, here, the ball is on the way down, negative 17.2. Why negative? Moving down, moving down. Ball is moving down. Okay, so I'm going to put negative 17.2. Teacher, they never draw scale leh. You draw your own scale lor. So you just need to mark at around negative 17. So I'm going to do 10, 20. Because I can't fit 17 if I use other scales. Okay, so 17.2 will be 17 somewhere here, I guess. All right, so we draw a straight line joining this point and this point. I'm going to use my pencil tool. Shape. Okay, line. You use your ruler. I use my pencil. You will draw a straight line. Okay, try to connect and pass through the important points on your graph, which I'm trying to. Okay, something like this. Ta-da! Okay. This is good enough. Okay, the graph is 3 marks. Okay, where are the marks, you ask? Well, let me show you. Okay, if you draw a straight line with positive value of V on the t-axis, to the t-axis, you get 1 mark. So basically, from positive, your V is positive. Start correctly. Straight line passes through 1.25, 1 mark. Continue with the same straight line until 3 seconds, 1 mark. So you don't really even need to plot 17.2. You just need to draw a straight line like that, 3 marks. This is an old question. It's from summer 15. As time passes, the question get more and more strict. Later on, you need to pass through this coordinate one. This coordinate needs to be 3.0, negative 17.2. Okay, so that will be safer. All right, so there's another way that you can check your answer, which I will not do now. You see from this graph, you can read your U. This is 10, and this is 20. So ladies and gentlemen, U looks like 12 to me. So if you know what to do, you can actually use this 12 to help double check just to confirm at least one of these values. Okay, so that's it. So in this example, a bit long because I took some time to break it down for you, you learn that there's positive and there's negative displacement to show whether you're above or below the starting position. You learn that you can use gradient to describe the velocity. You also learn that the most important thing is time interval in this question, where you start taking zero, where you start taking your motion. So I suggest you always know your initial position. All right, and then the final part is just sketching a graph. Sketching graph normally carries a lot of mark, quite worth it. All right, that's it for this question. I'll see you in the next example video. Bye-bye.